Okay, so you've had a chance to look at a few calculations on density. We started our unit off by looking at some definitions of what fluids are, the definition of hydraulic versus pneumatic, and now we have to go through a few um, sort of science-based ideas to be able to understand how hydraulics and pneumatics work. And the first one was the fact that you looked at density and how to calculate density. The second idea we're going to look at is pressure and how is pressure created and how can it be changed. And so the first thing I'm going to give you guys is just some things to think about, some real life situations to think about. Why does a person wearing snowshoes stay on top of the snow while a person of equal mass wearing boots sink? So think about the whole idea behind how they constructed snowshoes and knew that they would work better than just if you were in your regular shoes. Why does it not hurt to lay on a bed of nails, but just hurts to lay if you had a couple of them to lay on? You'd probably poke right through your body. But laying on an entire bed does not affect it. Why is it easier to move or glide on ice with sharp skates rather than shoes? Why is it easier to cut with a sharp knife than it is with a dull one? So they all have to do with the idea of pressure and what affects or changes pressure. So pressure is the amount of force, we've talked about force already, so force in newtons, applied per unit area. So you've got to think about the amount of area that something is covering and the amount of force that's applied. So the formula for this is a lowercase p for pressure is equal to force, which is a capital F, over area. And so of course, since we have three variables, we have a magic triangle for this as well. It's going to be a pretty messy one because I'm doing this freehand. But we have force up here, we have area over here, and pressure, or P, over here. And so if we're calculating pressure, the pressure in newtons per square meter, so remember if we think we're taking force in newtons divided by area in meters squared, our final unit for pressure is newtons per square meter. So remember when we take the area of something. So for instance, the area of a circle. If we wanted to know what surface area is covered by a flat circle, area, we have formulas for that, is pi, so 3.14 times the radius, so our radius is just half the distance of us across a circle, squared. And if we're taking our radius, you'll see why we end up with the squared meters instead. We have radius, if we're measuring this, distance is always measured in meters. Well, meters squared is the same thing as saying meters times meters. And so that's why our final unit, so when we say meters squared, it just means that we've taken a meters multiplied by another meters. And that's when we're talking, anytime we're talking about area, that's what's happening. Same with the area of a rectangle. We're taking the length times the width. And this is measured in meters, this is measured in meters. So anytime you take a meter multiplied by a meter, you end up with meters squared. So that's where the units come from. So newtons per meter squared is our final units for when we're calculating pressure. Newtons is just a capital N, and meters, our area, is in meters squared. So let's look at a couple of examples. A flat bottom crate is 2 meters wide, 3 meters long, and 1 meter high. Its weight, force or force of gravity, remember that weight is the same thing as a mass's gravity on its mass. And it's measured as a force, so we have our answer in newtons is 1.2 times 10 to the 4. Calculate the area of the crate in contact with the floor. So first thing we want to do is figure out what's the area. This is a flat bottom crate. It's 2 meters wide, so it might help to draw a picture. 2 meters wide, 3 meters long. Oops, and it's 1 meter high. So it looks something like this. And we've got 1, we've got 3, and we've got 2 wide. So if we want to know what the total area of this crate is, all we really want to know is calculate the area of the crate that's in contact with the floor. So let's just say this crate is resting on the floor. It's really just the bottom of it that's resting on it, right? So what we really want to know is what is the area of the bottom of this crate, or what's in contact with the floor. If this is resting on the floor, really it's only this part of the crate that's in contact with the floor. So if we want to know the area, it's length by width. And so the area of this is equal to 2 times 3. So our area is 2 times 3 meters, which is 6 meters squared. And we know what our force is because they told us that it's resting on the floor with a force of 1.2 times 10 to the 4 newtons. So now we can calculate the pressure, which I believe is the next question. Yes. So let's use that, 1.2 times 10 to the 4 and 6 meters squared. Calculate the pressure the crate exerts on the floor. So our pressure is equal to force divided by area. That's equal to 1.2 times 10 to the 4 divided by 6. And we end up with an answer of 2,000 newtons per meter squared. Okay. Now, the other thing you want to know about the units for pressure is that, so they can be newtons per meter squared. And remember, in science, a lot of times they take units for certain things and they name them after scientists. Well, this was also, and newtons per meter squared was also named after a scientist, and his name was Pascal. And so newtons per meter squared is also known as a Pascal. Okay, and so sometimes you'll be asked for to convert between pascals to kilopascals. Remember, anytime you put the word kilo in front of any unit, it's just multiplying or dividing by 1,000. So a Pascal to a kilopascal is just dividing by 1,000 if you have to convert some. And if you were going back, kilopascal to pascal, you're multiplying by 1,000. And that's it. So anytime you put kilo in front of just a regular unit, you're dividing by 1,000 to get it, multiplying by 1,000 to get back. And just know that a newtons per meter squared can also be a Pascal. You'll see that in your textbook as well. Okay, and the final, how would the pressure change if the box were just standing on its end? So we're taking the same box with its large side resting on the ground. And what they're saying is, what if it were standing on its end, one of the small ends? So now it's standing like this. And this was, I believe, 2 by 3 by 1. So now all we have that's in contact with the floor is just the bottom end of it, the small end, which is just 2 by 1. So our area changes. So in this case, our area is 1 times 2, which is 2 meters squared. So what's going to happen to the amount of pressure that it's putting on the floor? Do you think it's going to increase or do you think it's going to decrease? And think back to the examples that we talked about at the beginning. The nails, laying on a bed of nails, snowshoes, ice skates, a dull knife versus a sharp knife. What's happening to the area when we're doing those things? So let's put that in. Our force stays the same. Our force was 1.2 times 10 to the 4. But let's see what happens to the pressure now. And you'll see what happens. So we end up with 1.2 times 10 to the 4 divided by 2 this time. And we end up with a pressure of 6,000 newtons per meter squared, or pascals. 6,000 pascals. That's a difference of 3,000 newtons per meter square, 3,000 pascals more. So look at what happens when we decrease the area, when the area gets smaller or the number on the bottom gets smaller, we end up increasing the amount of pressure that we're putting on it. So it's less pressure applied to the floor when we have the large bottom part of it, of the crate on the floor. As soon as we turn it on its end and you have the same amount of force but less area, way more pressure is being applied on the floor. So that, if you think about the bed of nails, if you just had one bed of nails, let's just say, sorry, we had like 3 or 4 nails sticking up and you tried to lay on top of those 3 or 4 nails, they're going to poke right through you because the pressure is so great. But if we increase the 4 or 5 nails that we've got sticking up to say 100 to 150 nails, now you've got more area and it's decreasing the total amount of pressure that you're pressing on it with. So that helps to explain why someone can lay on a bed of nails but not just on a few nails without going through.